Chapter C. The topic is Order of Arithmetic Operations. There are 5 basic operations of arithmetic, and they are: one, exponentiation. Number 2, multiplication. 3, division. 4, addition. And 5, subtraction. The order in which these operations must be applied is as follows. First, if the expression contains a power, replace it with its numerical equivalent. Secondly, if the expression contains multiplication and division in sequence, read the sequence from left to right and apply the operations in the order that they occur. And finally, with the expression reduced to a sum and difference of its parts, you can simplify this by adding and subtracting in any order. And we'll do some examples now. Three squared multiplied by 2 to the 4th plus 2 to the 5th multiplied by 6 squared. This expression for this answer 9 followed by 16 with a plus sign next, 32 followed by 36. Notice that we want to write 144 for that, 2. Now we can add the two quantities and the final answer is 1296. In another example, we have several kinds of operations applied here. Is to take 4 squared first and simplify, then continue with the other parts of the question. I'll write that. The answer is 2 minus 14. The last step in the order of operation is to add or subtract, and here we have a problem where we subtract, and minus 12 is the result. Another example, we have 7 minus 12 divided by 3 plus 2 multiplied by 4. So we write 7, this is equal to 7, minus 4 plus 2 times 4, which is 8. This is reduced now to only adding and subtracting. We have 7 subtract 4 is 3, 3 and 8 is 11. For example, 3 divided by 4 multiplied by 8, add 4 times 10 divided by 5, minus 2 divided by 3 multiplied by 3 again. We will do the multiplication and division first before adding and subtracting. You must do this work in the order in which the signs occur. In other words, you have to divide by 4 before multiplying by 8. Now, if you divide 3 by 4, you can look at that as 3 over 4, or 3/4 times 8. Here, you can see that 4 must be multiplied by 10 first, and then divided by 5, it as 40 over 5. Over here, we have 2 divided by 3 first. We can express that as 2/3 multiplied by 3. If you do the add 8, which is 40 divided by 5, and subtract 2/3 of 3 is minus 2. We have now 6 and 8. 14 minus 2 is 12. Another example, 4 squared divided by 6 squared times 12. Exponentiation first, 16 divided by 36, and then times 12. This can be seen as being equivalent to 16 divided by 36 times 12. 4/9 for that. I can continue to reduce this by writing 3 for the 9 and 4 for the 12, and 16/3 is the final answer. Another example, 3 times 2 squared plus 6 divided by 2 cubed multiplied by 4, subtract times 6 divided by 4, and followed by multiplying by 4. And so we say 3 times 4 plus 6 divided by 8 times 4 minus 6 times 6 divided by 4 times 4. To write, so you would write 3 times 4 is 12 plus 6 divided by 8 first times 4. 6 over 8, that's 3/4. 6 over 8 is 3/4 of 4, and 3/4 of 4 reduces that to 3. followed by minus. 6 times 6 is 36, divided by 4 is 9, and then 9 fours are 36 again. We have now only addition and subtraction to deal with. 15 minus 36 is negative 21. When brackets occur in an expression, the order of operations can be altered or changed by them. The general rule regarding the effect brackets have is that operations within brackets must be completed before continuing with the rest of the expression. For example, if we have 3 multiplied by 2 minus 8, the operation within the brackets, even though it involves only subtraction, which, if you recall, has the lowest priority of all the operations available, that because the expression is in brackets, it must be simplified before the multiplication is applied. Consequently, we would write this as 3 multiplied by minus 6. And finally, minus 18. Here is another example. We have 3 multiplied by 4 in brackets multiplied by 2 minus 6. Consequently, we have 3 multiplied by 4 times 2, which is 8, then subtract 6. Continuing within the brackets until 3 times 2, and that is equal to 6 finally. In the next example, we have 3 multiplied by 6 minus 2 multiplied by 5 squared. Subtract. So this is equal to 3 times 6 minus 2 times 50, which then becomes 3 times 6 minus 50. And finally, we have 3 multiplied by minus 44. And eventually, 3 times minus 44 is minus 132. Brackets occur in pairs, as you have already noticed in the examples above. If we have a leading bracket to start an expression, we must have a closing bracket at the end of it. Now, some expressions may have several sets of pairs of brackets. Such an arrangement of brackets is referred to as being nested. And here is an example. We have 3 minus 3 in square brackets, 2 followed by minus 3 followed by round brackets or minus 1, and finally the end of the expression. Way to handle such a problem. All other parts will be copied as you see it until the part that you're dealing with is simplified. So 2 minus 1 ends up with being 1. Notice that all the other parts of the expression have been written and so on. We have 3 minus 3, square brackets, multiply 3 by 1 is 3. And one by one, these brackets eventually are eliminated. 2 subtract 3 is negative 1. Multiplication must occur before subtraction. We have 3 minus 3 times minus 1 is plus 3, and that's eventually 6. I have another example. Another example is 2 minus 4 multiplied by, in brackets, 3 minus 2 squared multiplied by 4 plus 6, and closing square brackets. All other parts, symbols, and so on are recopied as they were given. So multiplication here of 10 is what we want. Subtract. We end up with something like this then. Notice I've dropped the time sign here because it's not really necessary. 3 minus 4 by 10. And then 2 minus 4, 3 minus 40. And then it's 2 minus 4 minus 37. Now, negative 4 multiplied by negative 37 will equal 4 7s are 28, 4 3s are 12, and 2 148 positive. And finally, 150 is the answer. In another example, I have 8 plus 1 slash brackets square 3 multiplied by 4 plus 2. Round brackets, square brackets. Now a slash like this, if you recall, means divided by. We can rewrite this then as 8 plus 1 slash 3 multiplied by 6, then 8 plus 1 slash 3 6s are 18. It ends up that we have a problem where we're taking 8 added to 1/18, and that is that's equal to 8 and 1/18, like that. The next topic is about taking roots. There is a common misconception that square roots of an example such as the square root of 4 plus 9 is handled like the square root of 4 plus 4 times 9. If I rewrite this 4 and 9 and put a times sign in between rather than a plus sign, so I will indicate that these are not the same by putting a slash through the equal sign. This statement now says the square root of 4 plus 9 does not equal the square root of 4 times 9. Square root of 4 times 9 is equal to the square root of 36. Now we know that the square root of 36 is equal to 6. Square root of 4 is 2 multiplied by the square root of 9, which is 3. That gives you the same answer. But on the other hand, the square root of 4 plus 9 is not 2 plus 3, as many might think. If we took the left-hand side and said, oh, well, could it be that this is the same as 2 plus 3? The answer is no, because 2 plus 3 is equal to 5. And the square root of 13, which is the sum of 4 and 9, is not equal to 5. Here's another example similar to the one I have just done. If we take the cube root of 8 plus 27 minus 64. Individually, the cube root of 8 is 2. The cube root of 27 is 3. The cube root of 64 is 4. This does not equal 2 plus 3 minus 4. This is totally wrong. But what it is the cube root of is the amount that you get when you add 8 and 27 and subtract 64, and that's minus 29. Now the cube root of minus 29 is the correct expression. It is not equal to whatever this adds up to, which if you see that 5 minus 4 equals 1. That would be totally wrong.